Hello everyone! This is my final science project for Mr. Nick's class, for you. So, this is my Goldberg machine. Let's take a look at it. Okay, so how is this going to work? First, we're going to throw a marble through this inclined plane, step number 1, which is going to fall into this lever, making it do like this and raising a flag, step 3. Then it's going to fall through a screw, bam, 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 and fall to another lever, which there's a wedge on the other side, popping this balloon, falling the marble through here, through the wheel and axle by another inclined plane, moving these, and lighting up the candle, difficult task. Then it's going to finally fall through the last inclined plane, fall into the last lever, and raising the last flag, finishing with 13 steps. Now, let's take a look at how this works. These steps are 1. Inclined plane, 2. Lever, 3. Raise a flag, 4. Screw, 5. Lever, 6. Wedge, 7. Pop a balloon, 8. Inclined plane, 9. Wheel and axle, 10. Light a candle, 11. Inclined plane, 12. Lever, and 13. Raise a flag. Let's start. See the flag race. See the balloon pop. See the candles light. And see the last flag rise. Some tries that didn't work. Talk to my kids. We actually made it. I want to thank all this to my dad who helped me build it. Thanks, Daddy. See ya, Mr. Nick. The kinetic energy would end up as 0.16802 by the mass and velocity of the machine. The potential energy would end up at 16.8609 by the height, the mass, and the gravity of the machine. The law of conservation talks that the energy can be nor destroyed nor created, and that's what happens with the ball traveling throughout the machine. Velocity would end up 0.4262, which is distance divided by time plus direction, which is east. Vectors found in this will have both size and direction would be the velocity and the inclined planes, which have an inclined direction going west. The acceleration would be negative 0.0218 by the final velocity minus the initial velocity over time. The force, which is mass times acceleration, would end up at negative 0.0404. The first law is present in the machine by showing that the marble stays at the same speed throughout all the steps unless it is acted by any step. The second one increases by the gravitational force, which is used all throughout the machine. Even though the third law doesn't appear in my machine, it explains that every time one object exerts a force on another one, the second one rewinds that force in the opposite direction with the same force. 5 of the 6 simple machines appear in my machine. The first one, a lever, is a solid bar that rotates and turns around a fixed point. In this case, it is a piece of wood that rotates around a needle. Then, the second one is a wheel and axle, which is a simple machine made of a wheel attached to a shaft or axle. In this case, it is a piece of wheel that is attached to another needle, which rotates. Then, a pulley, which doesn't appear, is a wheel with a groove rim or a rope or a cable that rides in a groove. Then, an inclined plane is a ramp, in this case appearing 3 times, as a tunnel. Then, a wedge is a simple machine that has a thick end and a thin end. In this case, it appears as a needle which pops the balloon. Finally, screws an inclined plane wrapped around a cylinder or cone to form a spiral. This appears as the spiral, which is centripetal force, which we'll learn later. Centripetal force appears in my machine when in the screw, when this force points toward the center of the circle. This makes the marble go round and round instead of heading just when it is the direction when it is thrown in. That is why it's called centripetal, when it makes a circle going round and round and round throughout the screw.